Hi, I'm Phil, and today I'm going to talk about my latest project in robotics. It's using the robot bit with Mecam wheels, and it's in a car kit that you can build yourself. And in this example, I'm going to use a remote control to demonstrate all of the movements of this robot. Okay, so I'm using a mind map, starting off at the top right. I'll describe the kit, what's in the hardware, what software tools you can use. And a lot of the time I spent was building the robot itself. I've got a project that I've already started. Then I'll do a bit of a critique of the kit. And finally, I'll give you some references. Okay, so the really interesting thing about this robot is that it can move in all directions, or it's omni-directional. And this is a big advantage in places where you can't turn. So it's been used in industry in places like warehouses. The US Navy use it for their freight control instead of using an ordinary forklift where they want to move sideways. They can quickly steer around. Also used in wheelchairs to give elderly people or disabled people a little bit more mobility. So it's a little bit easier to use. So here we can see the various movements that are possible with this robot. So you can't do this with an ordinary robot, but it's a sort of degree of flexibility that a robot playing soccer might need if they want to act very quickly. So you can go forward, and that's quite easily. Each of the wheels needs its own independent drive. And if you look at the force, they're all in the same direction. That is, all the wheels are pushing the robot forward. If you want to go sideways, though, you reverse the opposite diagonal wheels, and you can get a sideways movement right, or you can reverse this and go left. So this is the great advantage of a Mecam robot. And you can even go diagonally. That is, you could move as indicated by the arrow, right or left. And you can have a pivotal turning point around either the center back, or any of the wheels. So this again gives you a little bit more flexibility in maneuvering. And here it can spin on its own axis, or it can spin on one of the endpoints. So when you buy the kit, it comes from Kittenbot, and what you get is quite a number of parts that allow you to assemble the robot yourself. So besides the wheels, you also get very interesting collection of servos. And these servos with Lego Technique pins allow you to pin the servos directly to Lego parts. So these are all the bits and pieces that you get. And it uses a lithium battery with plenty of reserve. So for software, you've got a choice. You can either use software by Kittenbot called Kittenbot, and it's based on Scratch 3. But in my project, I've used the Microsoft MakeCode, and there's extensions available where you can use those in your own program. Now here's my project. I've got Kittenbot, and it's the Kittenbot robot bit, but I'm also using it with the TinkerGen BitPlayer. And the TinkerGen BitPlayer is going to provide the remote control for robot bit. Both devices use a microbit computer, and the communications between the two of them is using microbit radio. So here are my objectives. First of all, to construct the robot bit and control it with BitPlayer. And I want to be able to demonstrate all movements, the forward, reverse, all the turns, the left and the right, and particularly the sideways movements. And I also want to implement some safety features like emergency stops. Other objectives include, I want to provide some feedback to the user. So initially, this is going to be a remote control or a manually operated robot, but the type of feedback will be on the NeoPixels, which are on robot bit, but also provide feedback using the microbit LED array. And I'll show which particular movement has been selected by BitPlayer and transmitted via radio. And that command will be on the LED array on both BitPlayer and also on robot bit. So for communications, I'll be using microbit radio, and I need to create a remote control protocol. So for the hardware, we've got BitPlayer, microbit, and I need 2 microbits, and the kit, the robot Bit-Mecanum wheel car kit. So into the construction. So this was quite a pleasure to build, and it was my first Lego-based robot. So most of the parts are using Lego technique components, and they assemble quite well. But the really good thing about the assembly is that you can add on additional sensors. So there are no sensors come with a kit, and that's a completely new challenge, is to extend the robot to add additional sensors. So since it's omnidirectional, I really need to have sensors for detecting on all directions. So I wired it not quite according to the instructions. So it was opposite to some of the recommendations, and I had to observe the results at the end to see how it would come out. So for the wiring, it's just a matter of plugging in the cables on both the right and the left, and being careful not to have the wiring too loose, otherwise it interferes with the wheel movement. And here you can see some of the wiring just underneath the robot. Here's the front assembly with the panels removed, and the side view with the Kittenbot module sitting on top. Microbit is right next to the battery pack, and it's a 4,000 milliampere hour battery. And now on to a bit of the software. So the software to control the car is shown here, and it's all in small modules. I'm particularly using modules for each of the functions. And I start off on the left, the startup. And one thing that's interesting here, I'm trying to minimize the time to show a feedback message on the microbit LED array. So I'm using a hexadecimal hex list here instead of using numbers 1 to 16. If I go beyond 9, the scrolling time can impact on the performance of the robot. So this minimizes the delay. The radio commands are on the far left, and when I get a command, it's decoded. And if it's an emergency stop, I immediately turn off the motors on the robot. When it does stop, I also want to flash the LED NeoPixels that are on the module. So that's just underneath. Then just moving across in the middle, we have the manual control mode. So in the future, I also want to add automatic mode, but I need to add some more sensors to the robot to achieve this. And on the right, we have all the movements. That is for turning the motors on or off on each of the corners, and for forward, reverse, turning left, turning right, and also for the sideway movement. And for each of these, I've got an associated pattern for the NeoPixel strips. So very quickly going through all these routines, I'm setting up using the radio group 1, and I'm initializing the NeoPixel arrays. So at the moment, there's no automatic mode, but that's a future option. And the other car software is for the radio receiving, the forever, and the LED flash. And here are in detail the car movement functions. So after decoding that, I then send it off to an additional function to move the patterns on the motors. To control the robot, BitPlayer is used, and it also uses the microbit. And here is the software. So quite simple. On the right, there are event routines that detect when a key is pressed and the corresponding command is sent. So if I press key A, I show a north arrow, and north, south, east, and west are the feedback messages that I set up on on microbit. But I'm also sending the commands to the robot when any of those keys are pressed. In the forever loop, I'm detecting the movement of the joystick, whether it goes up or down, and that's what controls the ordinary movement on the robot. For emergency stop, you can either press the logo button, and the logo button is only available on microbit version 2. But I'm also using the left tilt and the right tilt to move sideways. So if you press the logo or buttons A and B or shake it, I then issue an emergency stop command. But I also vibrate the BitPlayer just to give some additional feedback to the user or the player. And here are the results. Very interesting construction, certainly not hard. So within about an hour, I built up the robot with Lego pieces. I was also able to control robot bit with the BitPlayer, and I used the MakeBit for both of these items. All the movements that I wanted were achieved, and I was able to get the radio communications to work. So perhaps we can have a look at the video now, what it looked like. Hi, I want to introduce Robot Bit with Mecanum wheels, and it's going to be controlled with BitPlayer. And BitPlayer and the robot are both controlled with a microbit computer. Now the controls on BitPlayer, there's a joystick control, and that controls movements of the robot. But we can also get additional movements by pressing the keys. The microbit radio is being used to transmit the commands from BitPlayer to microbit on robot bit. So let's have a look at how it operates. In addition to the feedback on microbit's LED display, we also have the NeoPixel display operating. So when it stops, it will flash red. We also have emergency stops. So if we shake microbit, it will also transmit an emergency stop, and we can use the accelerometer on the microbit sitting on BitPlayer, and it can also steer the robot. As a demonstration, if we wanted to go forward, we just simply press the joystick and we get one. We wanted to reverse. We wanted to do an emergency stop, we just shake it. If we wanted to turn left, we just simply tilt. Or if we want to tilt the other way, we're moving sideways at the moment. Shake it and it will stop. And shake it. Bring it back to the table. Okay, so we've got an emergency stop. I was a little bit slow there. Okay, so we'll just repeat some of those. We'll go forward, go reverse, goes move, turn right, turn left, and we can also move sideways. So at the moment we're moving sideways, and just reverse that sideways movement. And if we want to stop it, just shake. And that is Robot Bit with Mecanum wheels, and it's been driven by BitPlayer, and both are using microbit computers. Okay, so lots of interesting projects for the future, and in particular, I'm interested in adding sensors for obstacle detection, for line tracking, and I'll use the simple sensors to start with, but I also want to use some image and object recognition so I can detect traffic signs and do some alternative line tracking, and also be able to detect traffic signals. So overall, I'm quite happy with both BitPlayer and also the Kittenbot robot bit, particularly when it's compatible with Lego and microbit. I've already got a lot of the existing stock of Lego and microbit, so it's plenty of spare parts are available. And I have some of the Kittenbot servos already. So I've got some spare parts for the motors also. The batteries are easy to charge, and you get plenty of charge there for extended projects. So I would certainly recommend this robot kit, and I think you'd have a lot of fun with it. I guess what's a little bit on the downside is that there's no detailed technical documentation. So you can explore and you can gain most of that by doing and making your own project. So here are some of my references. I bought the kit from Seed Studio, and you can also get the BitPlayer from Seed Studio also. Plenty of information on the internet on how the Omni wheels or the Mecam wheels operate, and some challenges there on how you might actually use this in a particular robot application. So that's it for now, and see you later. Bye.